Jain everybody. Today we would be discussing the first lecture on blockchain architecture and design. So what do you mean by a blockchain? So definition, practically coming to the definition, is a decentralized computation and information sharing platform that enables multiple authoritative domains who do not trust each other to cooperate, coordinate, collaborate in rational decision making process. So there are some of the keywords in this particular definition which we have to keep into mind. And the first is decentralization. So nowadays, what we were doing in previous work, a centralized system was being there. So we have moved from a centralized system to a decentralized system. That is, in the centralized system, we were having a controlling authority. For example, I should give you that when we are doing a transaction in a bank, okay, so if I'm transferring some money from my account to my friend's account, then the bank server comes into picture for that particular transaction. The bank server verifies that if I have a sufficient balance which I want to transfer from my account to my friend's account, then it does that particular transaction successfully. But if that particular amount doesn't exist, then in that particular case, bank notifies me that the amount is more. So there, the central authority is the bank server which is coming into picture. Okay, but here we want a decentralized system. We don't want any central authority to be there which should guide us what computation we have to do, what information we have to share on that particular platform. So the first keyword which is important for the blockchain is decentralization. Second, we have to have this information on a sharing platform. That is, each and everything which we are doing should be transparent and it should be seen by each and every users of that particular network. Okay, like if the example which I took, I'm doing a transaction into my friend's account. In that particular case, I am doing that particular transaction. The transaction is a private transaction. We don't have the transactions as public. That is between me and my friend. But we have to, if everyone sees it, see, all the person involved in that particular network can see this. That means you are sharing that information. Okay. Then we want that we should not have multiplicative authority domain. That is, we don't want a single person to have a control on that particular network. There should be multiple users. They should have an authority of that particular whole network. How the multiple users? In this decentralized format, we are giving right to each and every user so that they can have that particular authority of doing it. Like in mathematics, we have equally likely or equally probable. So each and every event can occur equally. So here, each and every node which is taking part into that particular sharing platform should have equal right or should have that authoritative right in that particular domain. But here, one more thing is, we don't trust each other because all the users which are there in this particular blockchain are anonymous users. Like, we don't know each other. Like, we already tell our kids, or your parents might be telling you that you should not trust a stranger. You should not eat anything if somebody gives you. But here in this particular blockchain, we are going against that particular thing. We do not trust each other because these all users are anonymous users. So we have all those anonymous users which have that particular authoritative domain. Why do we combine? We combine for cooperation so that that particular process can be successfully fulfilled. We have to coordinate and we have to collaborate so that whatever decision which we are taking, it should be in favor of that particular process. So a blockchain is, first keyword is decentralized. Second is we have to share multiple, you have to share that information on multiple platforms. Third is we should have multiple authoritative domain. Then we have to trust the anonymous users. The person who we don't know, we have to trust that person. Why do we come together? We cooperate together, we coordinate together, we are collaborating with each other so that we can run that particular process, or we can take that universal decisions so that each and every person knows it. So here is the diagram. Here you can see we don't have any one person who has all those particular rights. It is being connected with this in this form, and we have a connection with each and every node. So we have multiple users, we have all those particular rights, and we are collaborating with each other. So this is the basic idea of the blockchain. Now comes how this particular blockchain into picture, or how we can define that. Normally, when we were using MS Word for sharing the information, I'm taking the example of Alice and Bob. She's Alice. Alice want to share some information to Bob. So what she will do? She will write all those things which she want to share with Bob into a Word document. When she is done with all those changes, she would transfer to, or she would send that particular document to the Bob. Okay. Then Bob will look into that, can see all those particular changes which are being done by the Alice. Now, if Bob has to do some particular changes, then Bob will make that particular updations and then again send this particular document through network or internet to Alice. So, in this particular thing, the major drawback was once Alice was updating the document, she updated the information and she sent it to Bob. Then Bob updated that particular document, made all the changes, and then again send it to Alice. So the main drawback with this particular sharing information platform was Alice and Bob, they both simultaneously cannot change this particular document. Okay, so we came from this Microsoft Word to Google Docs. Each and every person nowadays are using the Google Docs. So what does this Google Docs is doing? Google Docs is allowing you to update this particular information simultaneously. Means Alice can also update, and at the same time Bob can also update or edit this particular information. So the key word here is they can edit the document simultaneously. So in this particular thing, still the problem here lies is they both are updating the document which is being centrally kept at particular server or a machine. So here the main disadvantages come out to be you have a centralized environment. Still we have not moved from centralized to decentralized or distributed, which we want for blockchain. Okay, so in this we have an environment which is centralized. So now what are the drawbacks of this particular centralized system? We will look into this particular thing. So in the centralized system, we have first disadvantages, we have a single point of failure. For example, we used to have a client server technology. If server fails, all the clients won't be able to access the information which is there on the server. So all those clients not able to access the information on the server, that can be an example of single point failure of that particular centralized system. Okay. For example, we are doing these updations in this particular Google Docs only. Because I need a continuous internet connection. Without that particular internet connection, I cannot update these Google Docs. So the first thing which I require is I should have a sufficient bandwidth so that we can change or we can update that particular Google Doc. Okay. As the Google Doc is a server crashing problem doesn't exist in Google, because they have developed the application which is fail safe. Means Google server does not crashes. Okay, but if we are not using the Google server but normal centralized server, then obviously there would be a problem of centralized system or the server failure. So at that particular point of time, we have to look what all computers are being connected to the server and they won't be able to access that particular system. If server crashes, maybe it may be due to the network issue, maybe due to overburdening of that particular server, maybe some another network issue may arise in that particular area where that particular server is being kept. So we can have that if the server crashes or the system crashes, then we won't be able to update that particular document simultaneously. So these are the major problems with the centralized system which we wanted to overcome in blockchain. Same, if I want to keep that particular, if I tell you that all the bank servers or all the medical hospital servers, they keep a backup copy of the document which you are giving to them, or the bank transactions. So whenever we are keeping a backup, we want that our server should be fail safe server. Obviously, whenever there is a crash in the server or that particular computer hardware, then we can upload that backup copy and we can have that particular server again up. But we have to wait until and unless we can upload that particular backup copy. So the major drawback with this centralized system comes out to be we have to move all those particular documents if we are considering the server to be fail safe by keeping a backup copy. First is the single point failure. Second is if server crashes, then we have a backup plan for that. But we have to load, unless and until we load that particular database or we load that particular server data again, we won't be able to have that particular smooth going. So to overcome these particular problems, we have moved from this particular centralized platform to distributed platform. Okay, so this is the diagram where I can tell you that in this particular diagram I have described all the differences between centralized, decentralized and distributed networks. So in the first figure you can see that we have this as a server or a center point. Okay, so center point is basically the server which is responsible for all these particular things. These are the nodes or all the stations or the computers which are being connected with these particular links. If this particular server fails, okay, if this server fails, which is this one, if this server fails, then all the nodes which are being connected in this particular network won't be able to access anything which is on the server. So they get disconnected. So this is the single point failure problem which we have discussed in the last slide also. So this is single point failure. Okay. So in this single point failure, obviously we have a centralized coordination system. If that particular system fails, we won't be able to recover that unless and until we overcome that particular server crash problem or we load from that particular backup problem. Okay. Then comes decentralization. Here the decentralization is we have multiple coordinators which would have a group of the stations or group of the nodes which would get connected to them, and that particular coordinator would provide the services to those particular nodes. For here we have a coordinator C1, this is coordinator C2, this is coordinator C3, this is C4 and this is C5. I am naming them C7. These are some of the coordinators. So this particular C3 coordinator is coordinating with all these particular nodes with the links. By chance, if this particular server fails, C3 coordinator fails, even C3 coordinators fail, then these particular nodes can get the services done from C4 or C5 or C1 if they have a connection with them. So the problem which was there in the centralized, that if there is a failure, then we cannot do anything ahead. That problem was to some extent was overcome in this particular decentralized one. That is, if this particular coordinator fails, then they can have a alternate option. Another coordinator can help them out in fulfilling their services and computing all those things which they want. So the advantage of this is it allows you to have multiple fails unless and until this particular network divides into two different parts. Means by chance, if I have a if I have these two particular nodes as a failure, and there is no direct connection between C1, C2, C3, C4 and C5. Now these two particular nodes got disconnected. There was a failure in this particular network. So now this has become two different parts. One having C1 and C2 and another having coordinators as C3, C4 and C5. So we can have multiple failures which are allowed, but we have to look that that particular network should not get divided into two parts so that there would be no communication between that disconnected parts. Obviously, so we have multiple points of coordination in this particular decentralized system. All these coordinators are the point of coordination. So if you are not able to get the services from one coordinator, we can get the service from the another coordinator. The third diagram shows that it is a distributed one. In this distributed one, we can see each and every person has the right so that they can execute the job, or they can collectively combine and do that particular job. So they don't depend on one another. Like here, it was dependent on this server. Here we were having the coordinators on which the other nodes were dependent. But in this particular system, you can see we don't have any dependency on one another. If I don't get this particular node, then I can get the services done from another server also. Or I can have a equally likely condition so that we can collaborate with one another. We have to coordinate, like the definition tells us, we have to collaborate, we have to coordinate so that we can achieve that particular decision which we have to take for that process. So this is distributed. Each and every node are equally likely and they have to collaborate so that we can collectively execute that particular job. So this was the difference between centralized, decentralized and distributed systems. So when we are having this three architecture system, so basically first one is the centralized, which we have discussed that the main problem was if the central coordinate system CCS fails, then we get disconnected and we have to completely rely on one single center authority. Okay, this was one single center authority. I don't want that reliability that it should be on only one person. So for that, we have jumped from centralized to a decentralized one so that we can have the advantage of the decentralized. We can tolerate multiple failures as discussed, and unless and until that network becomes two different individuals or get partitioned into two different or get disconnected, till then we can have that particular acceptable or the tolerance range of that particular failure system also. So for that, in the distributed architecture, each and every is collectively execute that particular job. In this particular thing, we have a centralized coordination and to coordinate with each other and collectively develop that particular application. So in this modern platform, considering the blockchain as one, we want that we should overcome that particular centralized system. We can move to a decentralized, and further ahead is a decentralized system so that we can have a robust solution for all the failures which was occurring previously and the dependency which we were having on that particular robust systems. So now the same example. So now the solution comes out to be that in the blockchain platform we have this decentralized or distributed platform, and now we are simultaneously, Alice and Bob both have their local copies. They are simultaneously changing this particular document, and as and when they change this particular document, they are ensuring the consistency of the document. This is basically taken care of this network or the internet through which they are connected with each other. So for everyone, they are editing. Alice is also editing the document and Bob, they both are editing simultaneously, but the consistency is being maintained by this internet. So we have to ensure that whenever we are having this particular problem, the consistency should be there in the document. But this is for your In this, ideally they have their own copy and they are simultaneously writing in that particular thing. So everyone edits the local copy and the network is ensuring the consistency. Now comes the blockchain into picture, because there was blockchain helps in coordinating these particular from one document to another document, and whenever they have their local copies, they are not updating anything on the server. They have local copies and they are updating their personal copy, and the blockchain will do a synchronization from this copy to this copy. So we are doing a synchronization from one copy to another, and we will see the updated copy of that particular document. Even the Alice would see and the Bob would see. So these are the basic differences of this particular blockchain. Now, what was the concept here? I told you here that Alice has her local copy and the Bob has his local copy. So the basic concept of the blockchain is that each and every node has their local copy, and their local copy should be consistent. If this particular node N1 is making some changes in this local copy, then these changes would be reflected in each and every copy of all those particular nodes. So in short, the blockchain is a distributed architecture, that is each and every node has their local copy. When they make the changes in their local copy, then all the local copies should be identical, and then they globalize that particular information so that each and every node which is there, they have their local copy and updated or synchronized local copy. So that is the basic concept, that we have a distributed architecture or a decentralized architecture, where we are giving authority to each and every person in this so that they can collaborate and coordinate, and we can have that particular system or decision making done at this particular point of time. So this was the introduction to blockchain. In the next video, we would see how this particular blockchain can act as a data structure. Now, thank you for this.